Hey, this is Leetcode 73, set matrix zeros. And a fun fact about this, this was a question, I got this when I interviewed at Expedia a while ago, and I guess my answer impressed the guy enough where I got the job. So hopefully something similar happens to you. The premise is, given a rectangular matrix, if we come across a zero, just set its column and row to 0. And just ignore this in place part at first. But what would that look like? Okay, we just set the row and the column to 0. Another example would be right here, we're just going to set the row right here, and then the columns of these zeros to 0. And that might seem pretty straightforward, but there is a couple loops we're thrown for, like not actual loops, but there's a couple tricks. So let's walk through how we would actually do this. Where's my pen? There it is. Okay, so I think right off the bat, we're gonna have to go through everything. So, just as a simple way to start, let's just say we're just gonna go through like this throughout the matrix. And, we stop at each digit and we say, oh, it's a 0. Okay. Well, if we come across a 0, then I guess we just mark everything as a 0 on the rows and columns. Okay. Now we're going through here and we say, okay, that's a 0. So we'll just, the rows and the columns above and to the sides, we'll mark that. We continue, okay, we would mark here, and so on. But that's not the answer. So one subtlety is that, is realizing that if we read and write from the same place, we're going to cause this cascading effect where zeros end up spreading everywhere. So we need to be smart about where we read and write from. So one solution, which don't already think it's a bad solution, because it is a solution, it just has trade-offs, is that we read from, the input and we just write to an output. I'll just call that write to new matrix. And as we go through here, so, I'll just write input. I'm very impressed about how this is going. I thought this would be a lot worse. As we go through, we do the same thing, but say we just initialize it as all ones, right? Or something like that. As we hit our zeros, we just write these into our new matrix. So say we go right here. We'll write our zeros in. And we will never hit another 0 from our input array. And then we just return this. So that will work. Let's talk trade-offs. So runtime and space. So we just have to go through the matrix once. So it's O of m times n, which I'm actually going to call that, quadratic, because it's like, it would be, if it was square, it'd be n squared, but like this is our, ignore that. That's our runtime. And then for our space, we actually also require O of n times n extra space. So that could be really annoying if we have a really huge matrix. So how could we do better? Well, the prompt says do it in place, and we've already determined that we're gonna have to visit everything once at least. So let's not focus on optimizing the runtime. Let's see if we can get it in, not a whole separate another array. So what if, as we went through, we just kept track of which columns and which rows to mark as visited? I will just say, so say we're going through like this. Same array, 1 0, or let's see, 1 1 1 1 0 1 1 1 1. Say we just kept track in like two separate arrays out here and out here, just what needed to be marked as 0. So we go through, and we would keep going, and we say, okay, once we hit here, we just mark, okay, this one needs to be 0 and this one needs to be 0. And that's all we would hit. And so these would actually be less space than an entire new array. So we would, again, the algorithm, we would go through, we would mark the rows and columns that needed to be marked as 0. And then on our second pass, we would just mark these all as 0 and all of these as 0. So what could we call that? I'll call this store rows plus columns. And how's our runtime and space looking? So we're actually going to have to go through twice this time. So, but in terms of runtime, we're fine. It's the same, m times n, and I'll just put 2 because I like keeping track. Even though this isn't big O runtime, I just like keeping track of how many passes this will take. And then for our space, now we're using O of n plus n, because we're only using, m, which is one of the sides, and then n, which is the columns or the rows. So we've already done better, but this question does ask us to do it in place. And the reason I didn't just go straight to the in place answers, because I think it's more logical to think about it this way. So how would we do it in place? Well, constant space really, but let's take a look. So again, our base problem is, hey, where we're reading from and where we're writing to can't conflict. So we kind of need to divide up where we are reading from and where we are writing to. And in this example, we were reading from this area and we were writing to this area, this outside area, and then we switched it and we wrote from we read from the outside and we wrote to the inside. I would argue we can do the exact same thing, but just by moving these in place. So I will call this read, write from inside. Maybe I'll fix that title later. But let's use a new example. So 1 1 0 1. Okay. And let me erase. Okay, perfect. So instead of using these outside auxiliary arrays, we should divide it up. And I think this makes logical sense to do something like this. I can write straight lines, I swear. So we now have a couple different ways we can do this. So we can either say, okay, let's see how the outside affects the inside, or we can say how the inside affects the outside. Like we can start either way. I think it makes more sense. You can try it either way, but I think it makes more sense to see how the inside affects the outside first. And what do I mean by that? So same array, but let's just go through the interior one and see how that affects everything else. So, we'd go, so 1, no change, no change, no change, until we hit a 0, and we would mark the sides as zeros wherever we hit that. So I'll write that down. 1, 0, 1, 0, 1, 1. And so really this was a 0, and this was a 0. Oh, and also in the other examples, like these, they'll put the ones as whatever, in like 2, 3, 4. Really all we care about is zeros and everything else. So I'm just going to use 1 as a placeholder for anything else. So this is how this is how the inside affects out. And we have still the same array in the middle. So this is good. Now our outside should be correct, at least. I guess I should use green. Now we know these parts are correct, at least from how the outside sees them. So, okay, so now we saw how the inside affects the out. Now let's do how the outside affects the in. So that will look like something like, let me draw it again, 1, 0. I really should be doing a better job copy pasting these. Okay. Okay, so now we're doing how the out affects in. So now we go ahead and we just mark the outsides, how they affect the inside. So, I mean, really our algorithm would go like this, but I'm just looking at each of these and I'm marking the columns and then the rows. So I'm doing this because of this 0, it's like this. And if we look, I mean, I'll just do the answer manually right here. It would be something like, 0, 0, 0, 0. A lot of zeros, a lot of cascading. 0, 0, 1. I believe that's correct. Yeah. We'll notice that this isn't actually the same. What's different? It's the outside row. So what do? We saw how the inside affected the out, and we saw how the outside affected the in, but we also didn't say how the outside affected the out. And specifically, that means this part right here. Because if you'll notice, like this spot right here, this affects these regions right here and nothing else. And we didn't really say how that works. And vice versa. So we have one final step, which is, how whether the first row or first column should be set to 0. So our third step could be, okay, since we have zeros here and zeros here, we're just going to mark the top row and column as zeros. Oops, I can't draw any lower. I have a limit set on my drawing pad, so I can only go within a certain area of the screen. But okay, we have our zeros, and we just copy paste the rest of it, the inside over. And that is the answer. So in summary, what are we doing? What's the runtime? So we take any array, we say, okay, how does the inside affect the out, right to these things? How does the outside affect the in? Specifically, these guys, these rows, how does that affect the inside? And we update that. And then we update the outside one more time based on how the outside affects the outside, specifically the original outside. I'll say outside affects out. So that was annoying. I'm considering whether I should do one more example. Let's see how we're doing in time. It doesn't tell me. I think I can do one more example. They gave us this one right here. Let's see. So 0, 1, 2, they just do zeros here. Okay. New example. Zero, I mean, I'm just going to use ones again. Yeah. So we see how so again, and like do this on your own. Don't just watch me do it. Like see if you can walk yourself through the algorithm. So, you know, step 1 is inside effects out. So, you know, nothing really. 2 is how outside affects in. And so that would be here, here, and that's it. And our 3rd is how our outside affects out. So really, it'd be like this. As for runtime and space, we're still going over, so run space, I don't know how to spell, space. We're doing it in place now. So, you know, constant space, in place. Now our runtime, now we're still doing it. We still have to go through everything through the matrix. I'm just going to say we're doing it in m times n. What we're actually doing is one full pass, if you consider these two, and then we're doing one more m plus n pass with these. So let's go to the code and let's see how this would look. Okay. So our first step was okay, see how the inside affects the outside. And it will get kind of confusing. I think matrix, especially Java, the way matrix notation is, it's going to get really annoying. You just have to, I mean, you just have to understand the notation and be comfortable with it in an interview, because you'll perform worse in an interview for sure than your normal level. So we're just going to loop through the inside. I is less than matrix.length plus plus, and then same thing, but you know, looped j, and then we're actually going to go here. And then what was our strategy? We're going to say, okay, if one of these inside elements is a 0, we just mark it on the outside. So if matrix at 0, wait, no, let's see. No, we're going to say if matrix at ij equals 0, then we're going to mark, I'll say mark outside call. And all that is, it's just matrix at 0, j equals 0. And then the same thing, but I 0. So that was this step. In this step, we would mark this as a 0 and this as a 0. Okay, now we need to see how the outside affects the inside. So see how outside affects the inside. You know, similar for loop. I'm just going to copy paste that over. This is why writing code on a whiteboard is just so much worse. And with most interviews done remotely, I think that's a huge advantage for the candidate. So what are we doing? So if, where were we? So now for our second step, we're just going to go through each of these. No, let's see. No, we're seeing how the outside affects the inside. So we're going through each of these, and we're seeing how that affects the inside. So we need to go through talking and doing everything is hard. Yeah, so we need to loop through our entire inside, really, and just check the outside. One way would just be to loop through this, and then as we hit something, mark that. Or you could just go through the inside and then just check, you know, what is marked. So we're going to say if matrix at I is 0 equals 0. So this is checking if to the left, or no, if this is checking whether to the top or the left is marked as 0. And in that case, we'll mark it as 0. As you can see, the code's not that complicated. I mean, it's annoying with these coordinates, but once you get the idea down, the code kind of writes itself. Okay, so finally we want to see how the outside affects the outside. And we do that by saying, okay, at this point, was there a 0 or a 0 in the row, in the first row or first column? And rather than doing this as a separate step, I would argue that we can actually go ahead and just check. If in our first pass, we should just have a flag that says, okay, if we hit a 0 in our first, I guess this is not a good example, but if we hit a 0 in our first row or our first column, flag that, and then down the line, we'll just know to mark that entire thing as 0. So I will say Boolean first row equals false, because we'll just assume it's false until marked as true. And then down here, I will say if, let's see, something like if I equals 0. So, you know, if we're in the first, I guess we'll have to go through here now. We'll start from 0. So if I equals 0 and it is 0, then we're going to mark the first row as 0 later down the line. And the same thing if we're in the first column. So yeah, if at any point, like right down here, we would mark first row as true. And right here, we'd actually mark both, but we'd also say first call is 0. But we wouldn't change it because that would corrupt what we're reading from. Okay. So now for our last step, all we really need to do is just, you know, check if we need to mark the first row or first column as 0. So if, you know, first row, then, you know, we'll go through. And we'll see if I'm getting all these right. I'm, you know, whether the matrix.length or matrix.0, it's possible. Matrix at 0 dot j equals 0. And then, you know, same, we'll also zero out any columns. first column. And we'll just say I and 0. And then make sure that's dot length. So that should work. We saw how the inside affects the outside, how the outside affects the inside, and then 0 at any first row or first columns that we needed to. Let's see if this runs. Equals 0. There's a couple of these. Copy paste. Cannot find symbol. I at J. Oh, we should be still doing I here. And I. Great. Well, that passes the base case. And that's a blazing fast solution. So that's the set zeros question. If any part wasn't clear, let me know in the comments. Until next time.